Hello everyone, this is Marala Bhagyashree and my teammate Charanya. We are going to do the video on the project called Car Black Box. We are currently pursuing our 4th year in Electronics and Instrumentation at Dayanand Sagar College of Engineering, Kumaraswamy Layout, Bangalore. Currently, I am an intern at Emertxe Information Technology and doing the internship on embedded systems. We worked on the project called Car Black Box throughout the internship on MPLAB X IDE and executed it on PicSimLab software. Now let's move to the contents of the project. Topics learned during internship, introduction to Car Black Box, requirements for the project, what is microcontroller and microprocessor, PicSimLab overview, what is LED, CLCD and all the peripherals, matrix keypad, ISR, timers, project introduction. These are the contents of the internship. The topics we learned from the internship are introduction to C language, arrays and pointers, functional strings, storage classes, conditional loops and operations, introduction to embedded systems and introduction to microcontrollers, what is MPLAB X IDE, XC8, PicSimLab and also the operation of project on it, introduction to various peripherals of PIC16F877A, and we also attended multiple quizzes and webinars provided by them, and we also did the Disha workshop. The requirements for the project are MPLAB X IDE software, XC8 compiler, PicSimLab and the PIC16F877A microcontroller with 16 to CLCD, timer 2, MKB and tactile switches. Now let's see the introduction to Car Black Box. The concept of black box is mainly heard by us in the case of aeroplanes. Upon a catastrophe, the black box is used to analyze the root cause of the issue. However, the purpose of black box can go beyond this analysis, also known as event data recorder or accident data recorder. The black box can be installed in some automobiles to record various events. These events, which are electronically sensed, can often proactively detect any issue in the vehicle. Example, engine fault or the monitor fault or driving over speed, thereby doing proactive maintenance of the automobile vehicle. Considering today's busy life, everyone wants to reach the destination as soon as possible by ignoring the rules and regulations. By implementing a black box which would log critical activities on the car and take appropriate actions in case of rash driving. As mentioned above, the root cause of the negligence in the driving would be meeting the daily schedule and go off duty, or to earn extra money by illegal trips, etc. So by implementing the mentioned solution, it would be easy to keep track of how the vehicle is being used, handled and control the efficiency of the vehicle. The proposed solution is to log all the critical events like the gear shifts with current speed, the engine temperature, fuel consumption per trip, trip distance, etc. The system should allow a password-based access to the transport managers to view or download the log to PC if required. Here we'll discuss the working idea of this solution. As an extension of this idea, the data can be exported continuously to the cloud-based server where a centralized monitor can be done. This means the black box implementation is extensible as an IoT based solution as well. The goal of this project is to implement the black box using the PIC microcontroller and simulate various events by interfacing the microcontrollers with the sensors, etc. The advantages of this are it is a reliable device, easy to extract the data, easy to analyze the recorded data, it will not affect the privacy of the driver, and it is also helpful to car manufacturers to improve the car design. It also helps the insurance company and also the investigation team. Module alerts the accident to present mobile numbers stored in it when it's connected to GPS system, and the alert message includes the location in latitude and also in longitude. Simultaneously, we have a disadvantages for it. As the black box mainly consists of electronic circuits, there are chances of damage. Now let's see what is microcontroller and microprocessor. A microcontroller is also sometimes called as MCU, that is microcontroller unit, is a single integrated circuit that is typically used for a specific application and designed to implement certain tasks. Products and devices that must be automatically controlled in certain situations like application, power tools, automobile engine control systems, and computers are great example. But microcontroller reach much further than just these applications. Essentially, a microcontroller gathers input, processes this information, and the outputs a certain action based on the information gathered. Microcontrollers usually operate at lower speeds around 1 MHz to 200 range, and need to be designed to consume less power because they are embedded inside other devices that can have greater power consumption in other areas. But a microprocessor is an electronic component that is used by a computer to do its work. It is a central processing unit on a single integrated circuit chip containing millions of very small components including transistors, resistors, and diodes that work together. Some microprocessors in the 20th century required several chips. Microprocessors help to do everything from controlling elevators to searching the web. Everything a computer does is described by instructions of computer programs, and microprocessors carry out these instructions many millions of times a second. And these are the few differences between the microprocessor and the controller based on their performances and qualities. As we all know that we used PicSimLab for the implementation of the project, and we used PIC16F877A microcontroller for it. And these are all the components which are there in the microcontroller. They are LEDs, buzzers, keypad, SSDs, matrix keypad, CLCD, ADC, analog digital converter, GPIO, RTC, and temperature sensor also. CLCD is nothing but the character liquid characteristic display. In PicSimLab there are two types of displays. One is 16:2 display and 16:4 display, and the picture which is mentioned here is the 16:4 display, which displays the information on the microcontroller. It displays the ASCII character and some special characters. It is most commonly used display. Two types of communication modes are also there in this CLCD. There are 4-bit mode and 8-bit mode. This is MKP, that is matrix keypad. This is also one of the feature on the microcontroller we have discussed before. This is a keypad in which number of tactile switches are connected in row and column concept. This is used when more number of user inputs are required and still want to save some microcontroller input-output lines. These keypads are most commonly used in telephones, calculators, digital lockers, etc. ISR. It is interrupt service routine. An ISR is a software routine that hardware invokes in response to an interrupt. It must be terminated with the instruction. ISR attends to request of an interrupting source by clearing the interrupt flag and should save register contents that may be affected by the code in the ISR. When an interrupt occurs, the MPU completes the instruction being executed, then it disables the global interrupt enable. This places the address from the program counter on the stack. An interrupt is an communication process set up in the microprocessor or a microcontroller in which an internal or external device requests the MPU or MCU to stop the processing. Then the MPU or MCU acknowledges the request and attends to the request. This goes back to the processor and where it got interrupted. Polling. It is the process where the computer or controlling device waits for an external device to check the readiness or state, often with low-level hardware. Timers. Timer is an important application in any embedded system, which is a default peripheral which maintains the timing of the operation in the sync with a system clock or the external clock. Let's go to the project implementation. These are the requirements for this project. This is the dashboard screen. When the system is in operation mode, it would act like a dashboard which would show the current time, speed of the vehicle and latest event occurred. And once you log into the project, this is the login screen which will be visible. On press of the up or down keys, the system should prompt for password. The password would be the combination of 4 presses. Each press should be denoted by the star symbol. Every wrong entry will prompt the password max 3 times for every 15 minutes. Incomplete key presses, pause for 3 seconds would lead to default screen. See, once after we enter the password, if the password is wrong, then we'll get a delay of 49 seconds. That means the system will be blocked for 49 seconds. After the 49 seconds, you can retry again. And if the event is given, this is the event folder. Here this shows the event number, this shows the time of the event, this shows whether the event is on or no, and this shows the speed of the event. The main menu should contain 2 options: vlog, set time. The up or down keys are used to navigate. A long press of up key should enter the selected menu and long press of down key should log out. Idle screen for more than 5 seconds should log out. There will be a view log that will be shown after the correct password is entered. This view log should display all the events captured with log index starting from 0, like event number, event signature, event time, speed of the event. The up and down key will be used to scroll the entities. Rollover on reaching the max log entities. Entities is nothing but the events. The system should be live even while viewing the log. A long press of up key should take you back to the main menu. Set time should show the current time. The seconds field should blink indicating the field to be changed. The up key should be used to increment the time. Rollover on reaching max. The down key will be used to choose the field. And a long press of up key should take you back to main menu. These are all the event captures. Required events have to be captured and stored in the memory. Every event should have a format like event signature, event time, event speed. These events should be captured in real time no matter which mode you are in. This is the screen of the event G1 and this is the screen of the event G4. Like this it can store the events till G9. And if there is a event collision, like two or more events are going at the same time, there will be a collision between the events and it will be displayed like this, event collision. Thank you.
Let us look at the working model of the car black box project now. This is the default screen with the default time in the hours, minutes and seconds pattern. And then we have the status of the car, that is on. And then we have speed, which is indicated as 0. The event of the car is on and the speed is 0 because we are not doing any potentiometer action now. In order to increase the speed of the vehicle, we use potentiometer on this board, which is marked here as P1. So we calibrate the potentiometer here in order to change the speed. We see that as we go clockwise it increases and anti-clockwise it decreases. To change the gear, this particular switch is used as input. We see that it goes from neutral gear to gear, gear 1, gear 2, gear 3, gear 4, and so on. In order to access the menu, we click on RB3. I will reload it. We clicked on RP3 and this is a 4-digit password. It shows us the menu. Only if we enter the password, it shows us the menu. If the password is not entered in 5 seconds, it automatically dispatches. If we need to change the password, we use clear log and then change the password. In view log, we can see the events that we have performed previously. First, for example, we changed the speed and then it went from gear neutral speed at 43 to gear 1 at 43 and then gear 2 at 43, gear 3 at 43. So we did this using view log so that we saw all the events that took place. Changing the speed again and changing of the gear. Just changing speed. Here again using RB1, changing of the gear. We can also clear log, that is erase the history of events that have taken place. For this, we will have to enter the 4-digit password again. After, in this menu, select clear log and then enter. So all the logs are cleared successfully. In view log, there are no logs now because we have cleared all the logs successfully. This is how we created the car black box project. Let's open IDE where the code is saved. The MPLAB XIDE. Open the car black box project. This is the project we can view here. Under source files, we will look for main.c. Here we can see in the code, I will explain the code briefly. We see the header files that are included. Scrolling down, these are the connections that we have made for PIC16F877A microcontroller. Now this is where the header files are to define for micros. This is for I2C module. This one is for timers. This way we can create .h and .c files in MPLAB XIDE. The compiler used to compile these programs is the XC8 compiler. We will build the project now. Compiler runs for checking any errors. This project is successfully built.